Differentiation 2, second derivatives, type 1 basic. So when we're asked to find the second derivative of a function, all we have to do is differentiate once and then take that answer and differentiate a second time. So for example, if we have y equals x cubed, then if we find our first derivative, we apply our general rule by bringing down the power and taking 1 away from the power, and that's our first derivative. So our second derivative is written as d2y dx squared, and we apply the general rule a second time. So bring down the power is 2 multiplied by 3, which is 6, and take 1 away from the power, just leaves us with 6x. So in the second example, we're given f of x. So when we differentiate, we write down f dash x. And if I differentiate 5x, I get 5. And if I differentiate sine x, I have two things to differentiate here. So the trig followed by the angle. So we need to remember power, trig, angle in terms of our order of differentiation. So differentiating the trig first, we get cos 3x. And then if I cover the sine, I'm left with 3x. So differentiating the 3x, I get 3. So in other words, the first derivative is 5 plus 3 cos 3x. So always tidying up before you move on to your second derivative. So in order to write down our second derivative, we are differentiating a second time. So now we have a second dash, so it's like double dash. And if you were doing the third derivative, it would be 3 dashes, the fourth derivative, 4 dashes, and so on. So of course, if I differentiate 5, it's a constant, so I get 0. And if I differentiate 3 cos 3x, again, I must apply my rule power, trig, angle. So I only have trig and angle here. So I need to differentiate cos, so it's going to be 3 times minus sine 3x. And then I must differentiate the angle, which is 3x. And if I differentiate 3x, I get 3. So by tidying that up, my second derivative is 3 times minus 1 times 3 is minus 9. And then sine 3x. Okay, so in the third example here, we have y equals e to the power of x to the power of 4. So again, if we can't remember our sine or cos or exponential, we go to page 25 in our tables, and we see that if I'm looking at e to the x, we have e to the x as our derivative, and in the previous example we had cos and we had sine. So again, they're also there too. So dy dx is e to the x to the power of 4. But of course, our rule is just for e to the x, which means I have to also multiply by the derivative of the power. So if I differentiate x to the power of 4, I get 4x cubed. So now for my second derivative, we have to be very careful here because I can see I have a function in terms of x multiplied by a function in terms of x. So to differentiate a second time, I must actually apply my product rule. And again, I can see my product rule here on page 25. So I would have to say dy dx is equal to u times dv dx plus v times du dx. So that means I need to write down what is u. So I'm going to say u is ex to the power of 4, and therefore du dx is e to the power of x to the power of 4 times 4x cubed, again. And v is equal to 4x cubed, so dv dx is 12x squared. So bring down the power, take 1 away from the power. So therefore, if I sub into my product rule, I would say my second derivative has to be u times dv dx plus v times du dx. So of course, if we tidy that up, my second derivative is equal to 12x squared times e to the power of x to the power of 4. And then 4 by 4 is 16. X cubed by x cubed is x to the power of 6. So remember your indice rules there, adding the powers. and that's times e to the power of x to the power of 4. So that's my answer, or I could, take out e to the power of x to the power of 4 out as being common, which would be 12x squared plus 16x to the power of 6. So that's our answer there. Okay. So in general, what we would say is to find our second derivative, we want to differentiate in other words, find dy dx, which is the same as f dash x. So if our function is given as y, we'd get dy dx. If our function is given as f of x, we would find f dash x. We will simplify before we move on, and then we will differentiate again. I'm writing our answer down. If it's in terms of y to begin with, then it's d2y dx squared. And if it was in terms of f of x to begin with, it's f dash dash x. So if we go to page 356, we're going to do the following questions. So question 1, part 3, part 5, part 7, part 8, part 10. Question 2, part 6. Question 3, part 6. Question 4, part 4 and 5, and question 5, part 4, 5, and question 6, part 2. And then the second video, the next day, we'll look at type 2 of our second derivatives.